Hello everyone, welcome to Sharna classes. In this video, we will see the number system part 2. So first of all, we will look at octal to decimal conversion. So we have taken a number 265 base 8. Base 8 indicates it is an octal number. So 2 into. So we first of all, if you write the positions, it will be very much easier to find out. Is from the very right to left, you write from the 0 starting from the number which is existing. So 2 into 8 to the power of 2 plus 6 multiplied by 8 to the power of 1 plus 5 multiplied 8 to the power of 0. So 2 into 8 square is 64, 6 into 8 and 5 into 8 to the power of 0 is 1. So 2 into 64 is 128, 6 into 8 is 48 and 5. So 128 plus 48 is about 176, and 176 plus 5 is 181. So 181 base 10. Now 200 base 8. Similarly, we will do this 0, 1, 2. These are the position values. So 2 into 8 square plus 0 multiplied by 8 to the power of 1 plus 0 multiplied by 8 to the power of 0. So 2 into 8 square 64, 0 and 0. So is 128 base 10. Now for the fractional part, we see here is 200 base. So we will write like this 0, 1, 2, and from the right side of the decimal point we will write -1, -2. So 200. So 2 into 8 to the power of 2 plus 0 into 8 to the power of 1 plus 0 into 8 to the power of 0 plus 1 into 8 to the power of -1 plus 1 plus 2 into 8 to the power of -2. So 2 into 164, 0 plus 0 plus 1 by 8 plus 1 by 64. So 2 times 64 is 128. So rest of the part is 0, and 1 by 8 is 0.125, and 1 by 64 times 2 is 0.03125. So it is ultimately becoming 128.1.15625 base 10. So this is the output of fractional to decimal conversion. Now we will see binary addition. So in case of binary addition, we have to keep in mind some rules. 1 plus 1 is 1 0, 0 plus 1 is 1, 0 plus 0 is 0, 1 plus 0 is 1, and 10 plus 0 is 10. So let's do the summation. Is 1 0 1 1 and 1 0 0 1. So 1 plus 1 is what? 1 0. So carry 1. So 1 plus 1 is again 1 0, and 1 0 plus 0 is 1 0 again. So 0 again 1, carry 1. So 1 plus 0 is 1, and 1 plus 0 is again 1. Now 1 plus 1 is 1 0, and carry 1. So various put is, and this is your answer. Now let us take an example. Next example, 1011.01 plus 0111.11. Let's sum it. So what we will get? 1 plus 1 is 1 0. So 0 is there. Carry up. So 1 plus 0 is 1. 1 plus 1 is again 1 0. So 1 plus 1 is 1 0. Again here 10 plus 1 is 1 1. So 1 again carry up. So So again 1 plus 1 is 1 0, 1 0 plus 1 is 1 1. Place it here. 1 plus 0 is 1 and 1 plus 1 is 1 0 0 and carry up. 1 plus 1 is again 1 0, 1 0 plus 0 is 0. So here and here. So basically you are getting this answer. Now binary subtraction. So 1 minus, we have to know the sum rules before we will start subtracting to binary numbers. 1 minus 1 is 0, 0 minus 0 is 0, 1 0 minus 1 is 1, and 1 minus 0 is 1. Now you will be saying that why 1 0 minus 1 is 1. The thing is that if you convert 1 0 in terms of decimal, it is 2 in decimal, and 1 in binary is also 1 in decimal also. So basically if you subtract these two, what you are getting? 1 only. So 1 in terms of binary is also 1. So that is why we are writing 1. Hopefully you have understood. So let us do the, so let's solve this problem. That 1 0 1 1 minus 0 1 0 1. So 1 0 1 1 minus 0 1 0 1. So 1 minus 1 is 0 obviously. 1 minus 0 is again 1. Now 0 minus 1 we cannot do that, we have to take carry. So cut it out. So 1 minus 1 is 0 obviously, and it is giving here. So it becoming 1 0. So 1 0 minus 1 is 1 again, and it is 0 here. So this is your answer. Let us look at another problem here. 1 0 0 1 0 1 minus 0 1 1 0 0.10. So 1 minus 0 is 1. So here is 0 and minus 1. So we cannot subtract 0 and minus 1. So to do that we have to take carry from the nearest value. So here it is 0, it becoming 0, and it is giving 1 to the adjacent side. So 1 0 minus 1 is 1 again. 0 minus 0 is 0. Now here, look here. Now again 0 1 0 1 and 1 0. So the nearest number is here. So this number will give, it will become 1, and it will give to the nearest value. So again is 1 0 minus 1. Again it will be giving 1 out of 1 to the adjacent value, and it will become 1 itself, because 1 0 minus 1 is 1. So 1 0 minus 1 is 1, and 1 minus 1 is 0, and 0 minus 0 is 0. Now we will look at binary multiplication. Similar to normal multiplication we do in decimal, binary multiplication is also similar. So so here we have a problem, 101 base 2 times 111. So 101 in terms of decimal is 5, and 111 is in terms of decimal is 7. So we should be getting 35 in terms of binary. So let us write 101 times 111. So if you multiply everything, so 1 times 1 is 1, 1 times 0 is 0, and 0 times 0 is 1. These are the basic rules. So now 1 times 1 is 1, 1 times 0 is 0, and 1 times 1 is 1. Again 1 times 1 is 1, 1 times 0 is 0, and 1 times 1 is 1. Now 1 times 1 is 1, 1 times 0 is 0, and 1 times 1 is 1. So 1 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is 1 0. So again here carry. So 1 plus 1 is 1 0, 1 0 plus 0 is 1 0, and carry 1 plus 1 is 0 and 1 base 2. So if you want to check that whether your answer is correct or not, you can do just conversion is. So this is using the 8421 rule. So this is 1 2 8, then 8 times 4, then 4 times 2 is 8, 4 times 2 is again 16, and 16 times 2 is 32. So 32 plus 2 is 34, 34 plus 1 is 35. So our answer is correct. Let's look at another example. 111 times 11, so it will become 111 times 111. So 1 plus 1 is 1 plus 0 is 1 only. 1 plus 1 is 1 0. Carry up. So 1 plus 1 is 1 0. 1 0 plus 1 is again 1. 1 plus 1 is 1 0, and again 1 0 plus 1 is 1 1. So 1 here, and again carry up. So 1 plus 1 is 1 0. So 0 here, and place it here 1. So this is your answer. Now we will do the binary division. So similar to normal division, we do it exactly like that. So let us write. This is the dividend and this is the divisor. So we will, for divisor, we will discard these values because this is the preceding values which are zeros. So in terms of zeros, if they are in preceding values, just remove those. So the divisor, the dividend and the divisor. So 10 times 1 is 10, and the rest part we'll put up here. So it will be 100. So our answer is 100 base 2. So basically you are finding what? If you want to check that whether your answer is correct or not, look up here. It is 8 and it is 2. So 8 divided by 2 is 4. So this is 4. So our answer is correct. Let's look up at another example here. So again, let's do that. Remove those preceding. This is dividend and this is your divisor. Remove those preceding values. So it will be 100. So 100. So 1 times 1 is 00, and you will subtract it. So 1 minus 0 is obviously 1. 0 minus 0 is obviously 0. 10 minus 1 is 1, and 1 minus 1 is 0. So 1 minus 0 is 1. 0 minus 0 is again 0, and 1 minus 1 is 1. So we will not write that. Then for 3 values, we will, since we have three numbers, so all 3 numbers will come down. So 1 times 1 is 100. So our answer is 1 1. So since then count that how many bits are represented. So 1 2 3 4 5, and here 1 2 3 4. So if you place 1 also, 0 also, it doesn't matter anything. So since there are 5 bits to represent this number, we should be writing like this. So 2 bits are already occupied, so 0, so 5 bits. So this is your answer. Now signed magnitude representation. So what is signed magnitude representation? Suppose in decimal 5 minus 6 is minus 1. So we, in terms of decimal, we can tell that with the help of this minus sign we can say it is a negative number. But in case of binary values, it is quite difficult to represent it. So we represent the minus values or the negative values with signed magnitude representation. Signed magnitude representation is of 2 types: 1's complement and 2's complement. So let us see. Let us take an example of 5. So 5 in terms of 4 bit representation is 0 1 0 1. Okay, now if you want to show that in terms of -5 representation, we need to do this. So what does complementing means? Complementing basically means that you are converting 0 to 1 and we are converting 1 to 0. So 0 1 0 1, this is 5 base 10, obviously it is decimal, and this is your binary representation. So for 5 you need to complement it. So 1 becomes, so from the very left we start like this. 0 becomes 1, 1 becomes 0, 0 becomes 1, and 1 becomes 0. So this is your negative representation of -5. So these two are called MSB, and this one is called LSB. MSB stands for most significant bit. And LSB is least significant bit. So if most significant bit is 1, we will basically understand it's a negative number. So this is your 1's complement representation. Now another way of representing a negative number is 2's complement method. So let us take an example of 8. 8 in terms of binary is 1 0 0 0 is 2. So how do we do the 2's complement? We first of all do 1's complement. So 1's complement of this one is 1 becomes 0 and rest of the part becomes 1 1 1. This is your -8 in terms of 1's complement. Now if you add +1, what you will get? 0 1 1 1 plus 1 is 1 plus 1 is 0 1, again 1 plus 1 is 0 1, again 1 plus 1 is 0 1, and 1 is here 1. So in terms of 2's complement, 1 0 0 is your 2's complement negative number. But since we are not able to differentiate that these are two the same, looks like same but they are different, so we place minus sign to make sure that we will understand that it is a negative number which has been converted into signed magnitude representation of 2's complement.